All right, so what we're going to talk about is we're going to talk about completing the square. And we've done this, but this time we're going to complete the square so that we can change the form of a quadratic from standard form to vertex form, okay? So think about what standard form looks like. Right? And then vertex form, and we did all this on Friday where we graphed in all three of these forms. Looks like this. So what we're going to do is we're going to complete the square, but in a slightly different way than what we did when we solved, so that we can make our equation look that way, okay? All right, let's do it. Let's say that I have, and I'm going to give you some steps, so you can just follow the steps each time. It'll be the same steps every time. Let's say I have the equation f of x equals 3x squared plus 12x plus 11, okay? And I want to write it in vertex form. All right, here's what I do. First thing I need to do is factor out, because remember, we can't complete the square with a leading coefficient, and that rule still stands. So I want to factor out the leading coefficient. What's a leading coefficient? The 3, the number in front, that's right. And what you want to do is you just want to factor it out from the first two terms. Yes, that's exactly right. But we can't just get rid of the 3 because we don't want it there. So what we're going to do, we're going to leave it written in front, but you're exactly right. It leaves x squared plus 4x, okay? Leave a space here. This 11 is still here. I can't not include that. And what I'm going to do, remember before when we were completing the square, we'd find that good C and we'd add it here, but we'd also add it on the other side of the equal sign. Instead of adding it on both sides now, if I add it here, I'm actually going to subtract it here. Okay, because this time I'm working on the same side of the equation instead of going from one to the other. So if I add 5, then to keep the equation balanced, if I subtract 5 at the same time, it keeps me the same value, okay? So what I'm going to do is I'm going to find a number to go here. When I add it in here, I'm going to also subtract it from the same side. Because if you think about an equation, what we were doing before, we'd find that good C and we'd add it over here, right? And then we said, yeah, but it's an equation, so if we add it over here, we got to come to the other side and add it too so it stays balanced. Well, now, because I'm only working on one side, I'm going to add it over here in the parentheses, but then I'm going to come to the end of the equation on the same side and subtract it. So I'm adding and subtracting at the same time, because if you took an equation, any equation, and you said, if I had x squared plus 3x, if I came here and I said plus 2 minus 2, has my equation changed at all? It's still x squared plus 3x, right? It's just written a different way. That's essentially what I'm doing. So it looks like I'm going all around right now, but I promise I'm not. I only took the leading coefficient, I factored it out of the first two only. Okay? I left a space for a number, I don't know what it is yet, but I left a space. The 11 I left out of the parentheses because I only take it out of the first two. And I did a minus a number because I'm going to add and subtract at the same time. Okay? All right. Now, I'm going to find a good C. How did we find that good C? Divide B by and square it. That's exactly right. So for this one, my good C is going to be, 4 over 2 squared, which is what? 4. Now here's where it starts to get a little bit more confusing. This to me is the hardest step of all of them. Okay? Once you find that good C, you add the C in parentheses. Okay, so it goes here. But remember, I have to subtract the same value. What value should I subtract? What have I really added to this side of the equation? I put a 4 there, but really what I added was what? Do you see it? 12. Why? That's exactly right. Because this 3 sits out here, what I really added was 12. So what I need to subtract is 12. Do you see why? So I add the C in parentheses, and then outside of parentheses, if I can have a pen that works, outside parentheses, subtract C times that leading coefficient that you took out. So this is going to be 12. I told you, to me, that is the hardest part, is figuring out what number you're going to subtract there on the end. Whatever this is, times by what you put in there. What's what? The leading coefficient, that number out front. Well, because we did all that other with quadratics on Friday, so this was the last part of the quadratics part. You got it in your notes. It was all recap from Chapter P. We were just reviewing. This is the only new stuff.
I just remember
The what? The what? Oh my gosh, you remember the one messed up example he did. All right, now I'm going to factor, and once I factor and simplify, this is going to be in Vertex Form. It's like magic. So what happens is, remember, the whole point in completing the square is so that we get a perfect square trinomial, right? So I've got the 3 outside. How does this factor? If it's a perfect square trinomial, come on, y'all. I know it's early. Square root of the first sign, and the square root of the last squared. What's 11 minus 12? We just factored the perfect square trinomial right here. Remember that one where if the ends are perfect squares, and if the ends are perfect squares and you take the square root of each, multiply and double, you get what's in the middle, then it's an easy factor.
I don't know that. You talking about this?
It's just the square root. The reason we complete the square is so that we can do this. We take the square root of the first one and the square root of the last one, and we square it. Okay? Now looking at this equation, tell me what you know about the graph. What's the vertex? What's the that's exactly right. -2, -1. It's in vertex form now. Remember, a times x minus h squared plus k. Does it open up or down? Oh, up, because a is positive. Is it skinny or wide? Skinny. The bigger a gets, the skinnier the graph gets.
Okay, so why is it -2?
It's opposite sign inside the parentheses. Let's do one more. let's see. Let's say f of x equals.
What did we solve?
We didn't solve. We changed the form to vertex form. We changed from standard to vertex form. Okay, so let me come over here and show y'all real quick, because I think this is what Jada was asking too. Yeah. So the question is, I think how we're factoring is a question y'all are asking. So if you go back, if you think back to whenever we did that chapter P, let's see. If the two ends are perfect squares, and if you take the square root of the first one and the square root of the second one, if you multiply them together and double them and you get what's in the middle, then to factor it, you do the square root of the first, whatever this first sign is, and the square root of the last squared. So for instance, if I had 4x squared, 9, 2 is 18 minus 36x. Is that a perfect square trinomial? Is this a perfect square? Is this a perfect square? What's the square root of 4x squared? 2x. What's the square root of 81? 9. 2 times 9 is doubled is 36. So yes, it's a perfect square trinomial. So to factor it, I would do 2x minus 9 squared. So the process of completing the square takes something that's not a perfect square trinomial and forces it to be a perfect square trinomial. All right, let's look back at that problem now. Tell me the first step. What do you do first? Divide it by -2. Now, I'm going to tell you, if you start with negative x squared, divide it by -1. Okay, you don't want to start with a negative leading coefficient. All right, so I have f of x equals -2 times x squared, what else? Minus 4x. Okay, I'm going to leave a space here. That -3 is still out here, and I'm going to leave a space to subtract whatever I put in those parentheses there. Always do that, yep. Yes, yep. So you're good, that's exactly right. Close. You're exactly right, Jerome. Outside, well, you're going ahead and simplifying, but what you have to do, you can't subtract 4 because you here it's got a -2 outside. So -2 times 4 is -8. But it's right because I got minus -8. Okay, so those negatives will throw you. But I intentionally wrote it like that so you could see I am still multiplying by the LC outside. How's it factor? -2. X, close. Keep the first sign always. -2. Plus 5. What's the vertex? Close. 2, 5.
So, I guess I see what you're talking about. I guess. What if it's not like a 4? What if it's like a 5? You can't split it.
If it's an odd number, it's hard because you're going to have a fraction. You'll be able to square root it because you're squaring it here. But it might be a fraction. If that were a 5 in the middle, you'd have 5 over 2 squared, which would be 25 over 4. That's what you would be adding here and then multiplying and subtracting here. So it gets really nasty if it's an odd number. But it can be done. Same steps, it's just a fraction instead. Yeah, we'll do one together. We'll do it. Okay. While y'all finish copying that down, copy it up. Y'all are a tough crowd this morning. My goodness. What's the axis of symmetry? That's right, +2. X equals 2. Your axis of symmetry, good job, Cameron, by the way, is always the x part of your vertex. Yay? Nay? Oh, third block is going to hate today because they have to do what y'all did Friday and this. All right, we'll do another example. We'll do one with a not so nice leading coefficient. A not so nice number in the middle, I mean. Your book is going to give you some that are out of standard form too, so you're also going to have to worry with that, which is kind of stinky. You want to do a hard one?
Yeah.
If you've got your calculator, though, are y'all hot?
No.
Yes, I'm always hot. All right, tell me what I do first. Take out a 3. Is 5 divisible by 3? Mm-mm. I see y'all turning your nose up already. Leave it as a fraction. So I got 3 out front, right? 5 over 3 is absolutely correct. All the rest of my steps are going to stay the same. How in the world are you going to find a good C with that? Okay, so if you've got a fraction that you're dividing by 2, it's 1/2. You're exactly right.
It's 5 over 8, 6. So we do 25 over 6.
Look at you go. Yes, it's fractions. Yes, it's nasty, but the steps remain the same.
Wait, why is
And
there
you-
5 over 3?
That's what's in the middle. I had to divide it by the leading coefficient. Remember that number that's in front?
I see you have.
What's on the outside? It's going to be in here. I've got to put it out here too, yes. I've got to figure out what goes out here though. Because it's not 25 over 36. It's actually 3 times, whoa, Stacy, 25 over 36. Oh, right? Because whatever I took out in the front, it's got to multiply to what I put here.
So we don't.
Right?
Oh, no.
Would it be multiply 3 by both of those?
Did you multiply by 3 already?
No. I squared it to put it there, but I didn't multiply it by that number outside. So look back at one. Can I skip a slide?
Like you said,
All right, so here, you see I squared it and I put it here, right? Then before I added it right here, I had to multiply by this number on the outside. And that's how I got this number. That's okay. Look at it a
on the
second.
one before it, you like, is it because it's negative? Is that why?
That one's negative, that's why it was plus, yes. That one I took out a -2.
Is that why? Oh my lord.
Okay, the one before it,
The one before it's got like a
Okay, it had a 4,
Oh,
right?
okay, I wrote it down wrong.
Okay, okay.
All right,
So I multiply by that 3 outside, and that's what goes to both sides.
okay. Because I was thinking, okay.
You with me? Okay. All right, so yuck. We got to multiply this nasty fraction by 3, but because I have this nice fancy calculator that does it for me, 25/12. So now my question is, what is -4 minus 25/12? Because I can factor this easily, right? Square root of x squared is x, the first sign. The square root of this is 5/6. What do you get? Yuck, what a number, right? What is the vertex?
This 5 and this 3.
Negative. That's what's going to throw you every time. -5/6. -73. Change the sign in parentheses, keep the one on the outside the same. What's the axis of symmetry? Hi, Grayson. -5/6. This one was hard because of the numbers. This is, make sure you wrote this one down. This is number 27 in your homework.